Good day, Sir Manaloto, and this is my submission on the final requirements for ITEL 201, Object-Oriented Programming, which is titled Food Management System. Now, on to the next slide, which is the overview of the program. Purpose. The program is designed to help users efficiently manage a collection of food items, enabling them to perform operations such as adding new items, viewing the list, updating existing items, and deleting unwanted items. Problem addressed. Keeping track of items can manually be time-consuming and error-prone. This program addresses the need for a reliable and user-friendly system to organize food data, making it easier to store and retrieve information without losing important details. Features. The program showcases object-oriented programming principles, including polymorphism, inheritance, encapsulation, and abstraction. It also integrates with an external file to ensure that food data is persistently stored, even after the program is closed. Now, let's move on to explanation of the program structure. First off is the Atienza class, which carries abstraction. The abstract in the class defines shared properties, ID, name, and ensures subclasses implement display info. The class also contains getter and setter for encapsulation. Next would be the Zoe class, which carries the inheritance. This class demonstrates inheritance by adding new property category and implementing the abstract method. Moving on to the Jhed class, this class is where the CRUD is created and managed. The update features method overloading, while the delete features encapsulation to deletion by ID. Second to last would be the Vincent class. This class is where file handling is implemented. The save to file saves the food items to a CSV file, ensuring data persistence, while the load to file reads data from a CSV file and populates the food item collection. And finally, the Ranho class. This class serves as the entry point to demonstrate program functionality, and this is where you need to run the application. Let's move on to the next slide, which is CRUD operations and file interaction. First is the create in CRUD. This adds a new food item to the system if its ID is unique. Next is the read in CRUD. This displays all stored food items. The third would be the update in CRUD. This part modifies the name or category of an existing food item. And finally, the delete in CRUD. This part removes a food item by its ID. In the file interaction, in the save to file at the top is where it writes all food items to food.csv. And the bottom part, which is load from file, which reads food items from food.csv. Let's move on to the next slide. In the object creation here on the left, as you can see, food items, Zoe class, objects like food1 and food2 represent food items with unique details, ID, name, and category. In the manager, Jhed class, manager handles CRUD operations for the food items. File handler in the Vincent class. File handler ensures data persistence via file operations. And the method invocation here on the right, CRUD operations in the manager object. Add food item, update food item, delete food item, and display all items, modify and retrieve data dynamically. The file operations in the file handler object. Save the file saves the food list to a file, and load from file retrieves data, ensuring persistence. And now, on to the final slide, which is the summary of key learning points. Object-oriented programming in action in the first. Successfully demonstrated the four pillars of OOP: encapsulation, inheritance, polymorphism, and abstraction. Encapsulation through private fields and getters and setters. Inheritance with parent-child relationship extending functionality. Polymorphism with method overriding and method overloading. And abstraction with abstract classes and interfaces. 2. CRUD operations with persistence. Implemented create, read, update, and delete operations to manage food items dynamically. integrated file handling to persist data, ensuring continuity between program runs. Real-world applications are number 3. Design a structured system with multiple classes representing a clear hierarchy. Showcase seamless interaction between business logic, managing food items, and persistence layer, file handling. And finally, on to number 4, code modularity and reusability. Modular design allows for easily extending or adapting the program to new requirements. Interfaces and abstract classes enhance flexibility and scalability. And that's it for my presentation. Thank you, Sir Manoloto, and everyone for watching this video.